Hi, Assalamualaikum. I am BTLM Azli, a final year student of Bachelor degree in Chemical Engineering Technology Biotechnology with honors. My research title is a production of silicone adhesive patch via seaweed KAPPAPHYCUS ALVAREZII as a composite filler for the wound fillings. I am supervised by TS Dr. Ali Hisham bin Razak and my panels are Dr. Mozatuziha Binti Ahmad and TS Dr. Aisyah Binti Muhammad Rehan. My presentation slides will cover Chapter 1 Introduction, Chapter 2 Literature Review, Chapter 3 Methodology, Chapter 4 Expected Result, and lastly Chapter 5 for the conclusion. Next, I will proceed to Chapter 1 Introduction. This is backgrounds. For my proposal is a transdermal drug delivery system as known as the adhesive patches and as the skin patches. As a step, self-contained is a method to describe dosage of the drugs applied to the skin prolonged over the time. Revolutionary of the transdermal drug delivery system that caused a lot of skin response frequently fell off and had a lot of the other drawbacks, cited by Morrow T. 2011. It is consisted of more than pieces of the plastic dipped in the drug dissolved in the alcohol. Based on this picture, we can see that the patches have a three layer, which is the first layer is the backing layer, consists of plastic. Second layer is a drying adhesive, and the third layer is a liner. There are two purposes of adhesive, which is the work as a glue to keep the patch adhered to the skin, and second work as a suspension to maintain the medications in the place. Serious issues since the medication concentrations in the adhesive has a direct impact on the thickness. Some of these problems have been solved by using silicone adhesive to create semi-solutions of the microscopic concentrated drug cells. The medication is then concentrated in reservoir, which is subsequently added in the liquid form silicone adhesive to reservoir. Then utilize suspended medications in the semi-soluble substance solution. Silicone is bound by a semi-solid slurry of the microscopic concentrated drug cells, cited by Morrow T. 2011. Next is the problem statement for this project. What is the problem to solve? There are three problems to solve in this effort. Firstly, the composite film loaded with the seaweed nanoparticles should appear to achieve the highest mechanical strength. Second, the effects of the loading seaweed nanoparticles by analyzing the tensile strength, adhesive strength, as well as the surface morphological properties of silicone elastomer composite. Third is optimize the ratio of emulsifier in silicone composite and its characteristics using the response surface method RSM by means of design aspect on the interface of the filler and the matrix. Next, I will proceed the research objectives in this project. There are several objectives have been proposed to accomplish a specified research. Firstly, to prepare the nanoparticles from the seaweed for silicone filler to achieve the highest mechanical. Second, to prepare the silicone composite film containing the seaweed filler and characterize smooth tensile strength, adhesive strength, and surface morphology. Third is to perform the optimized ratio of the emulsifier in silicone composite and its characteristics using the response surface method RSM by means of the design aspect. Next is the scope of the study. These research scopes were developed in the Consequently to achieve effective progress toward the goals. Preparation of producing the nanoparticles from the seaweed using the ball mill grinder. Seaweed that has been chosen as the filler for this batch is the dry seaweed and it will be mixed with the silicone, determining the mechanical properties of the patch with the combination of the seaweed silicones and tensile strength and adhesive patches of the composite. Next, I will proceed to chapter 2 of the literature. In my proposals, there are two paper findings that I will be proposed, which is the first is the room temperature vulcanizing silicone rubber RTV1 and RTV2. The author is Lawrence by 2030. This research is to discover the diversity silicone optimized and the properties and also the process technology of products in all the major industries worldwide. From this handbook of the thermostatic plastic, I found basic principle of the silicone rubber and understanding about the RTV silicone. The second journal is the silicone adhesive in the medical application by Gary K. 2017. This research is to understanding the silicone-based adhesive technologies, application and characterization, emphasizing those self-adhesive materials often used in the skin contact application, including transdermal drug delivery. From the result, innovative product development using established silicone adhesive technologies, including innovative TDDS design. Next, I will proceed to Chapter 3 for methodology. This is the chemical and reagent that will be used in this project. The first is silicone elastomer, which will be mixed with the seaweed particle as the composite patches. Next, I choose the KAPPAPHYCUS ALVAREZII seaweed to prepare the seaweed to become the powder. And third is the ethosylated and propylated silicone surfactant. This silicone emulsifier designed to prepare the low to medium viscosity water in silicone emulsions. Avoid low molecular weight ethosylated silicone surfactant. This silicone emulsifier is designed to prepare the low viscosity water in silicone and organic oil emulsions. Fifth, a liquid alkaline silicone polyether copolymer emulsifier designed to prepare the water in oil emulsions with the excellent stability, flexibility, and adhesive. And lastly is my chemical non-diluted and low viscosity silicone surfactant. Silicone emulsifier designed to create the low viscosity water in oil emulsions. And next, this is apparatus and equipment that I will be used. Firstly, is the ball mill grinder. Is to grind the blend the seaweed into the nano size using the different size balls. Second is electronic weight machine to measure weight of the materials involved. Next is the speed mixer to homogeneously mix the silicone with the seaweed. And the fourth equipment is universal testing machine used to measure stress at back and strain at breadth. And fifth, a drying oven to dry the film to remove the moisture content. Next is the SEM, which is the scanning electron microscope to examine the surface morphology of the seaweed. And lastly, the peel testing equipment, which is to measuring the peel, tear, and friction properties of elastomer. And here is the flowchart of experimental procedure. The first step is preparation of the seaweed. A second step is dry the seaweed using the oven at 24 hours at 16 degrees Celsius. And third step is to grind the seaweed using the ball mill grinder. Grind the seaweed into the nanoparticle size. A fourth step is to verify the size particles. Examine the surface morphology using the scanning electron microscope, SEM, and image G software. This step 3 and step 4 need to be repeated until you get the nano size required. And the fifth is weighing the using an electronic balance. Weigh the silicone elastomer and emulsifier until you get the optimal ratio for the composition. This is the preparation of the composite film. Silicone elastomer will dilute with the emulsifier as a solvent using the optimal ratio, which is 1:1. And step 7 is a speed mixer. Mix the compositions at the 1350 rpm for every 15 minutes and repeat the speed until the composition mixes well. Eighth step is a preparation of film. Cast onto a glass plate of the film applicator. The film will be prepared for the thickness below than 140 nanomicron. And ninth step is a dry film in the oven. Set the temperature at the 40 degrees Celsius for the 1 or 2 or 3 hours and increase the temperature to 1108 degrees Celsius for additional curing at least 15 minutes. And step 10, tensile strength test. Test tensile strength of the sample using LR30K Universal Testing Machine UTM. And next is a chapter 4 expected result. For the expected result for my project FYP is the best nanoparticle size from the seaweed for silicone filler to achieve the highest mechanical strength. Then characterize the adhesive patch of the tensile strength testing using the response surface methodology RSM. And then get the minimum optimization ratio of the emulsifier in silicone composite and its characteristics. And for the lastly, chapter 5 is my conclusions. For the conclusion, in my project FYP is a long-term goal of the research was determining which silicone seaweed adhesive essence patch material is optimal. This research looked at the varieties of seaweed, silicone rubber, and the transdermal adhesive patch characterization. Purpose of sample optimization adhesive choose the sample with the greatest strength level at break. Mixing time, seaweed particle loading, and curing time are critical to the production of the adhesive patch. That's all from me and thank you.